Hey everyone, this is Derek, and this video is about finding the x and y intercepts of a linear equation. And so basically to find the x or y intercepts, to find an x-intercept, you're going to let y equal 0, and to find a y-intercept, you're going to let x equal 0, and solve for the other variable. So here's our y-intercept, x is 0, and then b is going to be the number, and then when we're looking at an x-intercept, that means the y is 0 because we're not above or below on the y, and so x is a value. So pretty much for any of these problems, what we're trying to do is this. That's the question we're trying to answer. When x is 0, what's y? And then when y is 0, what's x? So in this equation, if I let x be 0, I would have 4 times 0 minus 5y equals negative 20. And then this piece drops out, right, because it's 0. So a lot of times what you'll see me do in the next one is I'll just cover it up. So I go, when x is 0, this is what's left, and then I divide over by negative 5, and I get 4. And so we can write it out here too, and you can see, right? But it's a lot easier to just look at this and go, okay, so then if y is 0, that's going to take away this piece, 4x equals negative 20, so then x would be negative 5. So if you need to write it out, that's cool, do that. If not, you just kind of cover it up, and then x is 0, y would be negative 4, y is 0, x would have to be negative 5. Same thing over here. So those are the two questions we have to answer. This one of them is really easy. So when x is 0, this is always going to drop out, and then there's our y equals, this is going to be our mx plus b, and this is going to be our y-intercept every time. So that number on the end is our y-intercept. So that's going to be negative 8. But when y is 0, when we're in slope-intercept form, which is what this is called, and this one was standard form, but when we're in this form, then we actually have to kind of solve it out. So here I'll add the 8 over. Oops. There we go. And then we'll divide both sides by negative 3. And then that would be my not so nice x-intercept. And then typically, so just a note on where the negative goes on these. Negative 8/3, if you think of that on a number line, it's between negative 2 and negative 3. So if I write it this way, it's the exact same thing as if I write it this way, as is the exact same thing as if I write it that way. So those all are the exact same spot on the number line, 2/3 of the way past 2 is what that would be. So it doesn't really matter. Computers sometimes don't like this one, so do one of those would be the better choice in terms of where to put the negative. Okay, Marcos purchases a top-off card for his prepaid cell phone. His remaining balance B can be modeled by the equation B equals 45 minus 0.15n, where n is the number of minutes he's talked since purchasing the card. How much money was on the card when he purchased it? And then which intercept is this? So basically, after he put money on it, how much money did he have on the card? So if he hasn't talked at all, right, that's when he would have just purchased this, so the n would have been 0. And that says that the balance on the card is 45. And 45 is B is balance, so that is dollars. And which intercept is that? That would be, so this is the output, right? So that is we're putting in minutes and we're getting out dollars. And so that would be the B, which would be the B intercept, or the vertical one. How many minutes will he have talked when he runs out of money? Which intercept is this? Okay, so we're starting off at $45 on the card, and then for each minute, it's going to tick off, it looks like 15 cents. So basically we're saying, when is the balance going to equal 0? Starting 45 at 15 cents per minute. And so if I add this over here, I didn't really leave myself enough room there, negative 0.15n equals 45. Oops, sorry, that should be a plus because I'm adding it. And then we can divide that. And then n would be 300. And that would be the n-intercept, which would be the horizontal one. And then what is the slope of this equation? What are the units of the slope? Okay, so the slope of the equation is this, because that's what's in front of x. So the slope is negative 0.15. And then that is, remember, this is like our change in y over our change in x. And in this case, that's b is like our y, so it's change in b over change in n. And b is dollars and n is minutes. And so that means this is negative 15 cents or $15.15 in dollar form. So negative 0.15 in dollars, which is where we can think of cents, but per minute. Okay, so Diana just graduated, wants to spend time off in Sacramento. Before graduating, she saved $8,450 for this trip and plans to spend $650 per week on food, rent, and activities. If she's really bored, and graphs the amount A of her savings and the time T in weeks since her trip started. So the first part is which variable would be the dependent variable, which variable would be the independent variable. So remember, dependent is like what we would think of as our y, and that's not what we're probably going to call these, but it helps to think of x's and y's as we're sort of working it out. So dependent is like that, the one that is going to be the output. Independent is the one that's going to be the input. And our choices were if she graphs the amount A of her savings and the time T since the trip started. And so I think we're going to let's see, T be the dependent. No, T is going to be the independent. So the T is like the X, and then the A is like the Y. So depending on what week it is, we'll be able to see how much money she has. We're going to put in weeks and we're going to get out dollars. And that would be this one. So then part B is on which axis would the variables be most commonly shown? And so again, our T is going to be our input, our A is going to be our output. So A would be the vertical and T would be the horizontal. So that's this one right here. And then here is part C. Give the coordinate of the vertical intercept. Okay, so again, from back here, we decided X was going to be the T, Y was going to be the A. So let's copy that down, that we're putting in T's and we're getting out A's. That will just help us kind of keep our brain organized when we're setting up this equation. So the vertical intercept is going to be the A, and it's going to be how much money she started off with. Because that's at T equals 0, she had saved this much. So that is going to be $8,450. D, give the coordinates of the horizontal intercept. Okay, so the horizontal intercept, that is going to be the time when the amount in her account is 0. So this is when she's running out of money. So we're going to have to figure out what our equation looks like. So we want to know she's going to not have any money. She's starting off with $8,450, and each week she's going to knock $650 off that. And that's a time. And so now I can solve this and figure out how long until the balance would be 0. So I'll add that 650 over and then divide out, and I get T equals 13. So what does the vertical intercept represent? So that's what we were talking about. And again, let's kind of draw this and have it labeled. So this is amount and time. And so we're seeing something that looks like this. And then this 8,450, that's here. And then this 13, that's what we just found right there. So the vertical intercept represents, I'm not gonna write it out because my handwriting is terrible, but it's how much money she started the trip with, right? That's at T equals 0, that's how much money she had. And then what does the horizontal intercept represent? This is at week 13, she's out of money, she's gotta go home, she spent all her cash.